Now, I mentioned in a previous video that we could put our region of integration into different coordinate planes, and that's what we're going to show you right now. So suppose we have an object in three-dimensional space. So we have, one surface up here and another surface down here, and the region is, well, that's not the region, but we would cast the shadow of that region down onto the XY plane, right? So that region would get cast its shadow, I didn't make them look very alike, down into here, right? Okay, so that's the region of integration in the XY plane. All right, so this would be R in the XY plane. Okay, so how do we figure out these pieces? So we want up here, let me do that in blue right here, that's the top. So we'll say that that is z equals h of xy. And then down at the bottom, down here, we have z equals g of xy. Okay, so when we write our triple integrals, and then we have f of x, y, z, and then dv, I would go, for this particular one, I would say dz, dA. So A is the region, or excuse me, the area is for the region in the xy plane. And z would go from my bottom function, which is z equals g of xy down here, to my top function, which is h of xy up here. So this is the top, this is the bottom. And of course, what we're doing is we're stacking columns inside of this three-dimensional surface, right? So we stack the column in from bottom to top. All right, so that's the one we're most comfortable with. We've been doing that one for a while, but it doesn't have to go that direction. All right, so let's draw it again. But this time, let's make it so that we have two objects going like this. So then this region gets pushed back into the XZ plane, right? So R is in the XZ plane. All right, so then we have to think about the right piece over here, which would be y equals h of xz, right? Because x and z would be my variables here. And then this left piece over here would be y equals g of xz. So when I write my triple integral, the first two are for the region that's in the dA plane. So then fx yz is my function, and then it'd be dy dA, right? Where r is in the xz plane. So those would be x and z, depending on which order you want to go in or have to go in. And then down here would be my left, which would be g of xz, which would be my left value, my left side. And then my right side would be h of xz, which is the right? And again, those are for y. Now the hardest one to draw is actually the third one, because we're kind of looking at it straight on. So we have to pretend. So up until this point we've done xyz, xyz, like this. So for this one we kind of can't do that. So because if we look at it down the xyz plane, it'll actually be looking straight through, and you'll see nothing but the disk. So for example, let me show you in Maple real quick. Okay, so here it is drawn, and pretend the bottom is the xy plane. no problem, right? We can see we've got the top function, we've got the bottom function, we're good, right? And then that was the first one we did. And then now we imagine tilting it on its side. Let me tilt it 1 second. And this is the one we just did, where it's on the x z plane over here, and then there's our right side and our left side. Okay, so what's the problem? Well, if I push it to the back, you don't actually see anything, right? So if it's the YZ plane, that's the back wall. And if I look at it straight down, there won't be anything to look at. So that won't be any good. So we're actually going to draw the same picture we already drew, but we're going to pretend like it's Y and the Y and the X axis have switched sides. It's the only way to draw it so you can actually see it, because otherwise, that's what it is. The YZ plane is the back wall, which doesn't show anything. Okay, so let me draw that same picture, more or less, again, but we're going to change our axes. So this is still the Z axis here, but we're going to make this the Y axis here, and this is the X axis. We're going to reverse our order a little bit. Okay, so now we have our object, right? And they have a tummy, right? And then it has this region, and that region gets a reflection over here in the YZ plane, right? And that's the region R of integration, right? But it's R in the YZ plane. Okay, so then this would be, it's really like front and back. So this is the back portion, right? Because if we look straight down, remember we were looking at nothing but blue because this is the front, and then this is the back. So the back would be, let's think, G of XZ. Oh, excuse me, G of YZ. Because X will be our variable, sorry. G of, here, hold on. I'm trying to cram this in too small. So this is X equals G of YZ. And this will be X equals H of YZ. So we're trying to stack the pillars in this way for both of these, right? Pillars go in, it's like that. Okay, so then we take our double integral in the front over the region, and then the third integral will be from G of YZ, which is the back, to H of YZ, which is the front. And then we have our function, and then it's dx dA, right? Because we were using x. Now, a natural question to ask would be, what does it mean when you have this function in here? Because a double integral of a function finds the volume. What's a triple integral of a function? Very good question. Right, so that's what the next page says. If you take the triple integral of 1, that is the same thing as the double integral of a function, right? So let's just make this note. The triple integral over a solid, d is the solid, of 1 dv is the same as the double integral over the region of the height function, dA, which is volume. Very key. You can find volume two different ways. You can find volume with a double integral, or you can find volume with a triple integral. So far, we've been doing double integrals all over the place. Oh, and a little recall, area is the double integral of 1, right? So area is the double integral of 1. The triple integral of 1 is volume. But then what's the triple integral of a function? That, if the function, well, it has a few different applications, but for us, the one that's going to be key is this will be a delta. So that letter right there, that's a lowercase delta, right? And when it stands for density, hence the delta D, right? Delta is the Greek letter for D. So when you take the triple integral of delta, you will get the mass, right? When you integrate density, you get mass. So let me write that out. The triple integral over the solid of density is mass. Right? Those are the three big pieces. And again, we usually write density as delta. So let me just add that in. Density is delta of x, y, z. It's some function of x, y, and z. So that's a big piece. Knowing each of those is very key.